So here, actually, in conclusion, the first conclusion we give here, the business intelligence has actually a key element that runs in background to succeed in helping making decisions and automate the decision-making process, which is the data store in background. Generally, we talk about databases and database management systems, but not only. We may find other clues like whatever actually are the back-end engine to run to process data and to make the data, let's say, process activity. But generally, here we talk about the data store with the management, and the very famous utilities available are the database management systems. Constraints and rules, they might actually limit the work with those data stores in background because of permittances and denials, constraints and cascade constraints. They would actually forbidden the fluent work with the databases and the background solutions. Policies, they are rules that they have to be actually implemented. So we don't have the full capability of the engine in background unless the service permits that. Good. So as per notes here, it has to be actually recognized that this is a key element, the background solutions, the background engines in general. Those are case studies. Please refer to your book to read them. Please do. Originally, actually, the fundamentals of the business intelligence, it is the original story of the traditional environments and traditional information systems. Decision making means we have to have actually some clues to say yes and no, and to answer questions and to specify what we need, what we don't need, and so on. Originally and traditionally, actually, the systems run with an habitual and a very primitive, let's say, way. It's the paperwork. Yet everything is organized, and it used to give, let's say, coherent understanding and coherent, let's say, results at the end of the day, but with maybe delay, long time to process, to search, and to, let's say, maintain the data inside, and so on. The first and the initial, let's say, definitions of the data forces us to understand some terminologies. Yes, database has been found since long time. Not now. It's not new technology. It's a sort of a grouping of data correlated to finalize actually one work, one process, one, let's say, correlated project in question. When we talk about the database in background, we may talk about specific data, and we may talk about profiles and things like that. The word file means here we're going to specify a record, or let's say a profile, to be delivered from a database, from an entity, from an object inside the database. A record is something that actually we can relate it with the scenario of the file, since it is sort of a record. The record is a sort of a row that has actually related data to one object. A field here, it's one kind of data that actually represents many objects from the same entity, from the same, let's say, database object. We may talk about, for example, ID of all the students, username of all the students, email of all the students. The ID is a field, the username is a field, the email is a field, and so on. We are not representing an object. We are representing a field, a value, with its diversity. Each object inside the database management system and background has to have a list of attributes. Those kinds here, the records, actually, they are a gathering of attributes. The fields, in plural, they are attributes. The field, one field is an attribute. Whatever, an ID is an attribute, which is a field. The name is an attribute, which is a field. Email is an attribute, also, which is a field, and so on. This is a graph actually via which we can see the hierarchy of the traditional environment. We used to have actually the work with the files originally here, different types of files. And those files actually, they have to be actually sorted in sort of tables, like such a view here. And then after that, there have to be actually a list of queries to filter the output upon the need. This is an example of a query of a record. And then after this record here, it has fields. In this example, we have 4 fields. We may retrieve and manipulate fields one by one, depends on the scenario. And before communicating the data, it has to be transferred into a binary view. So it has to be converted into bytes initially, and then after into binary representation to be able to share it. The original here and the traditional solutions here, they present limitations in the sense of they are not relational, they are not smart enough to give 100% accuracy and 100% decision support. Some issues, like the data redundancy, we may find actually some key elements which are redundant. We may find the same ID more than one time. We may find the same email more than one time. We may find the same mobile number more than one time. This is a data redundancy, which is not accepted. It's not accepted. It reduces the quality of the decision making here, or the business, let's say, process. Inconsistency, it's in the sense of we may find actually values of attributes that gets changed across the time, upon time. Today is a value, and tomorrow it might be changed due to some different circumstances. So this is a problem also, the inconsistency of the data or of the values means. The dependence, it's one of the issues, means once we will need to change, for example, a field value, it has to be done after changing the related fields to that value. Otherwise, it will not let you. So we talk about dependence in between the entities and the other entities relationship. Yeah, and the original and the traditional environment, it is not flexible enough to add attributes, to add entities and objects, to diminish, let's say, to diminish, to reduce the number of the entities and the objects inside the database. So this flexibility is limited, and truly limited and highly limited. This is the traditional environment, no? And when we talk about the traditional environment, we talk about file-based databases or file-based stores, let's say. They are very poor in terms of security. They are exposed. We have files and we can explore them manually even. We do not need the database management system to explore them. This is actually a graphical view of what we were explaining here. We have actually departments and things like that, but at the end of the day, we have actually resources stored somehow and ordered upon the criteria, policies, and politics of the company. As we said earlier, database is one of the key elements to enhance the creation of a business intelligence environment or business intelligent environment. It is a kind of a store, or let's say data store, centralized in background, that has data correlated absolutely because related to the same project, something like that. DBMS, database management system, is the engine where the database is being created. It is the interface in between the external environment and the internal environment. The external environment, the interfaces, for example. Internal is the databases themselves. Yeah, and the database management system, DBMSs, they came with an enhancement to the traditional environment. Means they came with solutions to different issues and defined with the traditional environments. This is a sort of, let's say, a database management system that stores data entities. Yes. The relational databases, we talk about primary keys and foreign keys, and we talk about relations in between the entities. Jadwals, they have links with other jadwals. So we have to talk about a relationship in between the entities. And because of this relationship, databases, they are called relational databases. Relational database, because the entities inside the database, they have relations. They are linked to each other. Each entity inside the database has to have actually the view of a grid. It has to have records and fields. Actually, it depends on the architecture, how many records, for example, how many fields. It depends on the data, and it depends on the architecture of the data. To build a relationship, we need a primary key, and we need a foreign key. The primary key, he is a primary key in his table where it has been defined. And if we move it and click and create a copy of it in another entity, it would be called as a foreign key. So the link of those two, primary and foreign key, helps us to extract, let's say, to catch and to hand whatever we need from the data specifically and very correctly. Yes, an example of a relational database. Here we may find actually the supplier number, which is a primary key in the green table. It's available here as a foreign key inside of this part table relationship. Okay, actually, upon the use of the relational databases or the RDBMS, all the activities working with the SQL server, let's say on the database, SQL database, is valid. All the queries, DML and DDL, data manipulation language and data definition language, they are all valid to be actually executed upon the RDBMS. So yes, here it is actually another view where we can see an association table that has the idea of two tables to represent actually a relationship between this green supplier and this, let's say, project, whatever services association here, and another relationship in between this part here and the association here. So here actually is a tiny project, yes, but this actually makes us see the relationship in between the entities. The direction of the arrow has an impact. Background solutions, they are not only SQL-based database, but we may find actually the NoSQL database. The NoSQL database, it has the capability to have the attributes of everything needed, but to define only a process and, let's say, to have actually constraint of usage and daily life based on the use of a non-SQL based content. So we do not have to have a query to retrieve the data inside, and it is not sorted and ordered by using the SQL queries. So the NoSQL is a sort of a data store at the end of the day, but it does not use the SQL specifically. It uses other technologies to retrieve and to store and to manipulate data inside the environment where it has been defined. Those technologies, the database and their related technologies, they might be actually found in a cloud environment. Means you'll be paying the use of the database upon the cloud upon your needs only. It's not it's not needed to be paid daily, and since the project is requiring a database, so the payment will be continuously made. No, only if needed, only if used. Thus, we talk about databases and the cloud. Retrieval and insertion, plus the processing of data inside the database, is one of the famous capabilities of the, let's say here, database management systems. This is a very famous example of a database management system, the Microsoft Access. The capability of this jadwal here, actually, or this DBMS here, is to display the information about the fields we have, or the dimension. We may actually specify the field size, the field data type, if it is related to another object to be displayed. So everything is here available in a separate table, what we see it here in the down block here. This is the table architecture, and this is the list of properties related to every single attribute. Example of a SQL query. Have a look, please. I will not explain anything because we saw that, and immediately I'm going to pass to the content what we have to see. This is a view where we can see actually a relationship between the entities. This is a query generated using the Microsoft Access. It's a query, this one. So we are having a relationship between those two entities. To have a result at the end of the day, we have a condition also. So this is a query. It would be, see, this is the query icon. This one here, double jadwals, double squares here. Let's come to a conclusion here. Design in a database actually requires from us some predefined methodologies and approaches to succeed in designing the database. Amongst of them, we have to know actually the ways how we will access the data inside the database. So direct access or not direct access. And then if there are any constraints, limitations, policies that have to be implemented, it has to be designed. So process actually, it is one of the points that might contact me in a future time as a developer to limit or to add other extra features. So the policies, we may say that. One of the very famous approaches to design a very successful database and a powerful database and to work on a project is the normalization. We are having actually 5 normal forms here to change the data into what it has to look like at the end of when the project is ready. Normalization we talk about. They are a group of rules. Here we talk about 5 rules to make the data unique, not redundant, and trustworthy all along the lifelong actually cycle of the project in question. Okay, unless you have any questions, otherwise you can upload. Let's say you can ask any questions you have, please.